Hi scientists! Today we are going to be doing an awesome experiment that's super easy and really fun, and it shows us some really cool stuff. To join me in experimenting today, you are going to need a black marker. For the first part of our experiment, you want to make sure that it is a washable black marker. Okay. Next, you are going to need a coffee filter. All right, coffee filter. And then pair of scissors, a cup, and some water, and we're ready to go.
All right, now that we have gathered all of our supplies to do our fun chromatography experiment, first thing we're going to need to do is prep the coffee filter. So what we're going to do is we're going to cut this into a strip because that's going to fit most easily inside our cup. It works just as well whole, but for this very first experiment, we're going to cut it into a strip. All right. Next, we're going to take our marker, and it's okay if your strip is a little crooked. Next, we are going to take our marker and we are going to draw a little line right across the bottom there. Okay. Then we are going to put that in the cup, and we're just going to use the marker on top there. And I might trim a little bit off the bottom here, just like that. Because what we want to do is we want to make sure that our paper doesn't touch the bottom. So we're just going to let it sit just like that. Perfect. Okay. Next, what we're going to do, make sure that that's prepped. I'm going to add some water in here. And again, we want to make sure that it's not going to touch the bottom of the cup and the water doesn't come all the way up to our black line, but it should reach the bottom of our filter paper. So as we can start to see, is our black marker really just black? What we're noticing right now is a phenomenon called capillary action. And that's where these water molecules are traveling up these channels and they're being pulled up by one another. So the next water molecule is being pulled by the water molecule in front of it. And what's happening is as the water molecules are traveling, the ink in the black marker is dissolving into that water. But black markers aren't really just black. Black markers have reds and blues and pinks and purples and greens in them. And as those colors are being dissolved in the water, some of those colors are actually heavier than the other colors. So some of the colors travel a little bit further. So we can tell after even just a few minutes in the water that our black marker isn't really black. I see blue, maybe some green, some pinks, some browns. And we discovered this using a tool that chemists and other scientists use every day called chromatography. And chromatography is the process in which we separate out something into all of the parts that it's made up of. So just like we have separated out this black marker into all of the different colors that make up the black marker.
All right, so now that we have finished our chromatography experiment, what happens if we change some stuff? What if we use isopropyl alcohol instead of water? What if we use a Sharpie instead of a marker? What happens? Can we see all of those colors in different colored markers? What if you use a dark blue marker or a brown marker? What happens then? Make sure you experiment. And I want to thank Boeing for being our sponsor for these Science with Sara videos. And until next time, stay curious.